Let's try a simple question. Y equals to x cubed minus 3x plus 5. So step 1. Find the first derivative and the second derivative. So let's do dy dx equals to 3x squared minus 3. And the second derivative, d squared y over dx squared, gives us 6x. Oops. Now let's do step 2. We're finding the station point. We let first derivative equal to 0. So we have 3x squared minus 3 equal to 0. Then I have x squared equals to 1. So therefore x equals to 1 or x equals to negative 1. Then we need to find the y values. So we sub the x value into the y, which is here. So when x equals to 1, y is equals to 1 cubed minus 3 times 1 plus 5, which give me 3. Yes. So y equal to 3. Or when x equals to negative 1, y equals to negative 1 cubed minus 3 negative 1 plus 5, which gives me 7. So y equal to 7. So therefore, my stationary point is I have 2. One is 1, 3. One is negative 1, 7. Okay, second step done. And then the third step, I need to go determine the nature of station point. So for nature of station point, so we have to sub the first derivative stationary point, which is x equals to 1, into the second derivative. So I do is equals to 6 times 1 equals to 6, which is bigger than 0. So what does that mean? At that point is concave up. So therefore, 1 and 3 is a minimum. Turning point. And then we have to do the second one when x equals to negative 1. So my d squared dx squared, the second derivative will be equal to 6 times negative 1, which equals negative 6 and less than 0. Therefore, it's concave down. So negative 1, 7 is maximum turning point. Okay, good. And then we go step 4. We have to find the inflection point. So we let second derivative equal to 0. So we have 6x equal to 0, and pretty simple, we get x equal to 0. And we sub in to the y, we have initial here. Sub in here where x equals to 0. So we have y equals to 5. So therefore, 0, 5 is a possible point of inflections. And then we have to check the concavities. Step 5. Check concavity change. So how do we do this? So we make a simple small table to show you if concavity change or not. So let's do using the x values around your inflection point, which is x equal to 0. We know the second derivative equal to 0, and then we have to check on the left of this point, I pick x equal negative 0.1, and on the right of this point, 0.1. And now let's find your second derivative. I sub the value into the second derivative, which gives me negative 0.6 in here and positive 0.6 in there. So what does that mean? It means at this point here, this is concave down, and in here, this is concave up. Therefore, concavity change. So therefore, my 0.5 is a point of inflections. Long process. Okay, we're almost there. Last step to go is find the x-intercept, y-intercept. So for this question, we have y-intercept is we let x equal to 0. Then we back to the original question here. You can see x equal to 0 is y equal to 5. So it's pretty simple. We have y equal to 5 is your y-intercept. And x-intercept in here is hard to find. So we leave this part here. Now we get all my points, intercepts, and my inflection point. And also I have found 2 stationary points. One is the maximum turning point and my minimum turning point. So give me a lot of information I can sketch. So I draw my x-axis and my y-axis. So y-axis and x-axis and 0. So I label this is 1, and my point is 3. So here's a point. This is my minimum turning point. 1 and 3. And also a maximum turning point at negative 1 and 7. 1, 2, 3, 4, 5, 6, 7. Okay, let's say here. So that's maximum turning point. -1 and 7. And we know at this point here is concave up, and the point here is concave down. So I'm going to label all these things on my graph. So this is concave up here. Yeah, and here is concave down. It really shapes up as this is a maximum and minimum. And also, don't forget I have y-intercept at 5 here. This one is a y-intercept 5. So it's here, 1, 2, 3, 4, 5. Here, nice, 5, this y-intercept. And also this point is also my inflection point, which is let's see, 0, 5. So I label the inflection point. Okay, so now I can pretty much make my curve. It changed the concavity into from concave down all the way to that point, and then change the concave up. So nice and smooth, and I join them up. Yep, done.